test. Hello. How's everybody doing? Can I get everybody to say hello so I know who's on? All right. Uh, if you got any questions, go ahead and pop in them into the text, uh, or you can send an email to Mike the CFII at gmail.com. Uh, Stuff we're going to be talking about tonight is go over navigation stuff, and also we'll be talking about IFR holding patterns. So to get things started, uh, let's first talk about some VOR navigation ideas here that are going to help out with especially the FA test questions for the IFR exam that can be kind of confusing. Uh, but one thing to know when we talk about the VOR and how we uh, deal with its indications, one thing you need to understand about the VOR is that it does not care what direction the airplane is facing. That point is extremely important. So for example, if we had each of these four VOR OBS is tuned to 360, what that's referring to then is that you're tuned to the 360 course or radial, depending on where you are relative to the station. If you're on this half of the station up here, then you're going to see a from indication. If you're on this half of the station down here, you're going to see a to indication. Uh, mm, mm, all right, that's fine, David. If you need to send anything, you just send it to the email. Uh, Now, if you're on this side of the course line, then your needle is going to indicate over there. You know, your course deviation indicator is going to indicate that the course line is over to your left. If you're over here, it's going to indicate it's over to your right. If you're over here, it's also going to indicate it's over to the left. And over here, it's going to indicate that it's over to the right. And with regard to that, again, uh, the airplane's heading does not matter with any of that. Where these questions can get confusing is if we're given an indication like this, where they're all tuned, let's say that we'll have each one of these tuned to 270. So what I recommend when you're going through these questions is to uh, draw a little dot out there and identify the 270 radial. Identify the reciprocal and identify the perpendicular point. And then what you have to do in your head is, again, disregarding the airplane heading, you need to pretend that you're going that direction. So if you're going on a heading of 270, then if you're over here, that's going to be a 2 indication. This one's also going to be a 2 indication. This one's going to be a from indication. And this one's also going to be a from indication. Now again, pretending that the airplane is traveling in that direction, over here, this setting is going to show that the course line is off to your left. Over here, it's going to show that the course line is off to your right. Over here, it's also going to show that the course line is off to your right. And over here, it's going to show that the course line is off to your left relative to the direction that you're trying to fly. So what I'm going to do now is we're going to go through some practice exercises. So if you got some scratch paper handy, you might want to get some so you can draw some of this stuff out. So let me pull that up here. Okay, so on the first one, here the question is which airplane coincides with the VOR indication shown. And what we have is the VOR that's tuned to 360 with a 2 indication and a left needle deviation. So what I recommend doing is to go to your note paper, and you're going to want to draw out the VOR, draw out your 360, draw the perpendicular, or draw the reciprocal and the perpendicular point. And, you know, again, we had 360 with a 2 indication and a left needle deviation, which means that, we're going to the station, which means that we have to be somewhere on this half, and we have to go to the left to get on course, which means that we are somewhere on this half, and so that means that we must be somewhere down in this sector. So if we go back there, we can see that the only airplane that's down in that sector is letter D. And so that should be the right answer, and there you go. So as I'm going through these, try to draw them out on your paper, see if you can figure them out on your own. If you have any questions, again, just pop them into the chat. Or if you're having trouble, just let me know, and I can go over it more specifically. So here we have a 360 from the station, and the course deviation indicator, the CDI needle, is off to the left. So 360 from, and we have to go left. So if we just redraw that out, we've got 360 from the station with a left course deviation. So we draw our VOR, radial 360, the reciprocal, and the perpendicular point. And then we just got to isolate the different quadrants here. So we're going from the station, which means that we have to be somewhere on this side, the from side. Anytime we cross that perpendicular point, it's going to flip from a to a from. We have to go to the left to get on course, which means that we're somewhere over here. And that means that we must be in the upper right-hand quadrant. And if we go back to the drawing there, we can see that the only airplane in the upper right-hand quadrant is represented by letter B, which should be the right answer, and it is. All right. Now, something like this can be a little tricky, as we're 360. We got a left needle deviation, but we don't have any to or from indicator, which tells you that you should be right on the perpendicular point. Hey Steve, how you doing? Thanks for joining in. So what we're doing now is we're drawing these out to figure out which letter represents. Now notice how I'm not even looking at the letters right now. I'm just going to go right to my paper and draw this out. So we got a 360 left needle deviation, and we're not going to or from it. So 360 left needle deviation and not to or from. So again, if we draw out our VOR and our radial 360, draw the reciprocal and the perpendicular point. So we know from the left needle deviation that we have to go left to get to the course line, which means we must be somewhere over here. Because we're neither to or from the station, that means that we have to be right on the perpendicular point. So we must be somewhere on that line. So if we go back to the ones that are selected there, letter C is the only one that it can be, and that's the one that it is. Looking at this one, starts to get a little tricky. So we've got a 270 to the station, and we have a right needle deviation. So 2702 with a right needle. Jamie, how you doing? So again, to figure out which one of those, I'm not even looking at the options. I'm just going to go right to my scratch paper. Well, try to remember what it was. So 270 to the station with a right needle deviation. So we got 270 to the station with a right needle deviation. So again, draw out your VOR. You're going to draw your radial. This time you're going to draw the 270 out here. So 270. We're going to draw the reciprocal, and we're going to draw the perpendicular point. And then we just need to isolate the two elements here to see which quadrant we're in. So if we look at the to from indicator that says we're still going to the station, which if we pretend that our airplane is going that direction, means that we are still somewhere on this half. And because we have to go to the right to get on course, you may need to turn your head sideways to look at that. But if you're going 270, then that means that you're flying that direction. And if you have to go to the right to get on course, you must be somewhere down here. So we're somewhere in the bottom right-hand quadrant. And if we go back to the selections, we see that letter D is the only option that matches the criteria there. So that is the answer. Remember, the actual direction the airplane is facing does not matter. Hi Dan, how you doing? Hopefully you're doing all right, holding up in Hawaii. I'm sure we all feel sorry for you. Anyway, so let's try another one. So, which airplane coincides with the VOR indication? So this one we have east. We're going to the station, and we have a left needle deviation. So I'm sure you're all feverishly working with your scratch paper right now. Uh, so you're going east to the station, left needle deviation. So let's look and see how that's going to go. So we're going east to the station with a left needle deviation. So again, we draw out our VOR, draw the radial 090. We'll draw out the reciprocal point and the perpendicular. Uh, Again, we need to pretend that the airplane is going that direction. Uh, so if we're going that direction and we're going to the station, that means that we must be somewhere over on this side. If we have to go to the left to get on course, again turning our head sideways there, we can see that that must put us somewhere down in this lower left-hand quadrant. So we got to be somewhere down there. And if we go back to the selections, we can see in the lower left-hand quadrant there's only one airplane there, and that's letter E. So that must be the one. Getting a little trickier still. Here we're doing a 135 heading from the station, and we have to go to the right to get on course. So, going to our scratch paper, 135 to the station, and we have to go right to get on course. Let me make sure that was right. Yep, 135, sorry, 135 from the station, and we have to go to the right to get on course. So 135 from the station. So we draw our little VOR symbol out, which of course looks like a scribbly circle. We're going to draw out 135. We'll draw out the perpendicular, or I'm sorry, the reciprocal, and then the perpendicular. Again, we pretend that the airplane is traveling in that direction. So if we're going that direction and we're from the station, we must be somewhere down here. We have to go to the right to get on course, which means we must be somewhere over here. So we have to be somewhere in that quadrant. And if we look at the options here, the only one that's in that quadrant that matches that would be letter C. All right. Oops. What we got here? We got 135 to the station, and we are right on the course line. Right on course. All right. So draw our 135. We're going to the station, which means we must be somewhere over here. And we're right on course, which means we must be somewhere right on that line there. So let's see which one matches up with that. And that'd be A. So again, things that confuse that is that you can see airplane A is pointed in the opposite direction, but again the VOR does not care what direction the airplane's facing. That's why best to draw it out and pretend when you're dealing with the VOR, always pretend that you're going whatever direction you have set in your OBS selector there. You're moving on. This is a skill set that I don't know that I've had to use in real life, but there are a few FAA test questions that ask you to do this. although you could do, some pi r squared and things like that, uh, there's a rule of thumb that works out good for determining approximate, oh, I'm sorry, this isn't the DME arc distance. This is just determining how far off course you are. So there are some FAA test questions that, ask you based on this, how far off course are you? So looking at the uh, information here, it says given the DME or GPS distance of 8 nautical miles from the VOR, based on the indications that we have, how far off course is the airplane? So the way we figure that out is using this rule of thumb, 200 times the number of dots off course times the nautical mile distance, and then we have to divide that by 6,000, and that'll give us our nautical miles off course. So looking at this one here, we have to take our 200 times the number of dots off course, so that's times 3, times our nautical miles distance, which is 8. And then we are going to divide that by 6,000 to get our nautical miles off course. So take our 200 times 3 times 8 equals 4,800, I think, right? 200 times 3 times 8. Yeah. Then we divide that by 6,000, and it tells us that we are 0.8 nautical miles off course. Let's see how we did. Bing. All right, let's try this one here. So we have a DME distance of 10 nautical miles from the VOR. How far off course is the airplane? So again, taking our 200 times the number of dots off course times nautical miles, dividing that by 6,000 is going to give us our number here. So that's going to be 200 times our 2 dots times our 10, divide that by 6,000 is going to give us our answer. So so we got 4,000 up top here, and we divide that by 6,000, and we get 0.67. We'll call it 0.7 nautical miles. Which ends up being the answer that we're looking for. So 200 feet per dot, or times the number of dots off course, times the number of nautical miles off course. Now, talking about a DME distance. DME arcs, if you're asked to fly one on a, especially on an arrival or departure procedure, they can add quite a bit of distance to your flying, so it'd be a good idea to be able to factor in that distance in your flight planning. Depending can use up quite a bit of fuel. So in this case, again, we could do some, pi r squared stuff, but we're not going to bother with that. We're going to use a rule of thumb, and that is just taking 100 times the number of arc degrees, times the arc distance, and we're going to divide that by 6,000, and that will give us our approximate distance along the arc. So looking at this example here, we can see that we're going to take our 100 times the number of arc degrees. So you can see that this is the 147 and this is the 118. So if we take our 147 minus 118, so we got 29 degrees. times the arc distance, which is shown right here. So that'd be times 16. So we got 100, oops. So we get 46,400. And if we divide that by 6,000, we're going to get about 7.7 nautical miles along that arc. Hopefully you guys are working these along with me. You got to do them a few times to remember, or just remember the little rules. It's about as simplified as I can, as I've seen and as I can make it. So here we got two different arcs that we can measure. And if we take the short one here first, again, we find the difference between the two radials. So we got 201 here, and we got the 176 there. So 201 minus 176. So that's going to give us 25 degrees. We got 100. Well, I guess we could just do that. Times the distance of 15.3. And we're going to divide that by 6,000. So 2500 times 15.3 divided by 6,000 equals roughly 6.4 nautical miles. Looking at the second one here, we've got 95 degrees there and 176. So if we find the angular difference, that gives us 81 degrees times 100. So we'll add our two zeros in there. Multiply that by 15.3. So 15.3 gives us 123,930. If we divide that by 6,000, it's going to give us 20.6. So you can see that starts to look like some real distance when you start getting into it. All right, 20.7 nautical miles, but I suppose if I rounded correctly. So that's how you figure those out. But you can see, you start adding 20 miles to your flight, that can start to add up some distance, start to chew up some fuel. So good to be able to figure that out if you had to. Next thing we're going to talk about, there are FAA test questions that ask you to do something here. It says, what OBS setting will center the CDI with a from indication? So we have the 090 from indication, and we are 5 dots off, which is 10 degrees. So again, on these, I recommend drawing them out. So we've got the 090 from the station, which means that we're somewhere on this side. We have to go to the left 10 degrees, which means that we're somewhere over here. How far over? Well, 10 degrees over. So that means that if we tune the OBS to 100, That would center that up with a from indication. We're going to pretend that that says 100. All right, let's try another one. This one's a little trickier. So here we want to know what OBS setting will center the CDI with a from indication. So we're looking for we have a to indication in there now. We not only want to center it, but we want to get the reciprocal. Um, since we're looking for a from indication. So again, drawing that out, we draw our little VOR. We're tuned to 270. Oh, that's poorly drawn. Two seven zero. We're still going to the station, which means we're somewhere on this side. And we have to go to the left. 2, 4, 6, 8. We'll call it 8 degrees. So we have to go to the left 8 degrees. So that means that we're somewhere over here on this side. How far over? 8 degrees over. And if we looked at up over there, that would be 8 degrees there. So that would be 262. And we want the reciprocal to center it up with a from indication. So we use our -2 +2 rule for figuring out reciprocals, and that gives us the 0.82 radial. Or you can just add or subtract 180 as necessary. Probably best to do if you're taking the test with a calculator. And if we look here, we can see that 0.82 would center that up. So again, on those test questions, really best to draw that stuff out so you can visualize what it is you're trying to do. Next one we're going to talk about is trying to determine our position relative to indications that we have with our dual VORs here. So we've got the top VOR tuned to the Rochester VOR, and we have the bottom VOR tuned to the Geneseo VOR. And the question here is, while westbound along the Victor 2, the Rochester 099 radial, are you west or east of Megan intersection? So let's look at that. Again, something here would be good to draw out. But you can see that we're tuned to 099 here. Or I'm sorry, we're tuned to the reciprocal of 099. We're tuned to 269. Now we don't know what heading the airplane is on. We would assume that they're probably heading westbound, but it doesn't matter. Always just pretend you're going the direction indicated on the VOR needle or on the VOR indicator. So we're going to pretend that we're going west and we're going to the station, which means that we're somewhere on this line heading that direction. And then it wants to know where we are relative to Megan intersection, which is right here, and indicated by the 062 radial off of the Geneseo VOR. So on the second VOR, we have 062 tuned in. We have a from indication. And if we were going outbound on that 062, and we had to go to the left to get on course, that would mean that we are somewhere over here, which means that we are still east of Megan intersection. Again, always just, even when you're trying to determine your position relative to something, the easiest thing to do is just pretend in your head that you're going whatever direction you have shown up there, and try to visualize that on your chart. All right, let's try another example. So here, the scenario is we are southeast along the Victor 31, and we want to know, are we northwest or southeast of fault intersection? So uh, looking at the indications here, we can see that the top VOR is tuned to the Rochester VOR, and we have it tuned to the 132, and we are going from the station. So that means that we're heading, pretend that we're heading that direction, and it shows us to be right on course. And fault intersection is indicated right here, and it's referenced by the 070 radial off of the Geneseo VOR. So we can see that we have the 070 radial tuned in. We have a from indication, and we have to go to the left to get on course. So if we pretend that we're on that line heading outbound, and we have to go to the left to get on course, that means that we are somewhere over here, which means that we are still, or we are currently southeast of fault intersection. All right. And you see that that one is correct. So as I talk through this stuff, hopefully you're trying to doodle it out on the on your own scratch paper, trying to come up with an answer, and hopefully you're staying well ahead of me. We'll see how that goes. So we're going to see here the scenarios that we are eastbound along the Victor 2, the Rochester 099. And it wants to know, are we east or west of Lorth intersection? So you see that the top one is tuned to Rochester. We have sorry about that, wrong button. We're tuned to the 099, and we were heading from the station. So that we're going to pretend that we're going that direction. Second one here, we want to know where we are relative to Lorth intersection, which is right here, referenced by the Geneseo 055 radial. Here we can see that we have 055 tuned in to help us reference that. We have a from indication, and we have a right needle deflection. So assuming that we were trying to fly outbound on there, and we have to go to the right to get on course, that means that we're somewhere over here, which means that we are still approaching Lorth intersection. How far off are we? Well, we still have 2, 4, 6, almost 8 degrees left to go. So we are 8 degrees shy of Lorth intersection. So that means that we are somewhere west of the intersection. All right, so those are fun. It's going to get even more fun now. Now we're going to talk about the horizontal situation indicator. The HSI is a great tool. It's a common reference used, especially now in GPS displays and primary flight displays, and it's a tool that you're definitely going to want to learn to use if you're going to be doing any kind of IFR flying nowadays. When we say horizontal situation indicator, what you want to pretend is that you're taking the display that you see and just laying it flat on the ground ahead in front of you, and kind of using it as like a sand table to determine where you are relative to stuff. The big difference between one of the big difference between the HSI and and the radar VOR indicators, this one does account for the aircraft heading. Oh, there are several FAA test questions that ask you, to reference your position relative to the HSI. And again, they can be pretty confusing. But just looking at the indications here, you can see that in the middle you have your airplane. So that's you flying along going that direction. What direction? Well, whatever you have indicated up here. And what this is telling you is that the VOR is generally to your left and your course line is to your left, and it looks like you are flying away from your course line. Again, if you pretend that that's laying down on the ground as like drawing it out in a sandbox, then you are flying away from your course line, and the VOR is to the about your 10 o'clock position to the west. So you're tuned to the. Oh, sorry, hitting the wrong button here. You're tuned to the 270. So whatever's on the head of the needle there is the course line that you're tuned to. So that would be your 2 indication. That's what your 2, and this would be your radial or whatever from it. One of the nice things about the HSI is you don't have to worry so much about what we call reverse sensing. As it will, whether you have it tuned in 180 degrees out of phase, it's still going to show where you are relative to your course line. A trick I learned to, especially regarding the FAA test questions, to determine your position relative to these is to take the figures book that you have, and you rotate the HSI representation until north is always facing up top. And once you do that, then like if you look at this one right here, with north facing to the top, you can see that the VOR is off this direction and the course line is down to the south of your position there. So and you're heading, let's see, what does that one have you? It doesn't even give a to or from indication on there. But again, it doesn't really matter with those. So if we look at these relative to north, let's see what we have tuned in here. We have a 270 and we're on a 315 heading. So if we change that to where it's relative to north, we're tuned to the 270. The CDI needle's off over there, and the airplane is facing that direction, and the VOR is somewhere over there. So if you're looking at this on a phone or a tablet, just kind of rotate your display to where north is facing up, and it shows that the VOR is off to your left and the course line is down to the south, or off down to the south of you, relative to you. So what that's telling us then is that we must be over on this side and we must be somewhere up here. And we're heading on a heading of 315 degrees, so the only airplane that's heading 315 degrees is letter B. So rotate it to north. Uh, Again, the VOR needle is showing that the VOR is over that way relative to you, and then relative to you, the course line is that way. So that means that you must be on this half of it and in that upper right-hand quadrant. Let's try. So therefore, we must be letter B. So looking at this one here, again, what we want to do is rotate the display until north is facing up. And once we do that, we can see that the VOR is off to our left and the course line is up to the north there. So relative to the VOR, we must be over here on the right side where the green squares are. And because our course line is to the north of us, we must be in the bottom right-hand quadrant. The airplane is facing a direction of about 235 degrees. So in the display, there's only one airplane that's facing 235 degrees. It's in the bottom right-hand quadrant. What I like to do on the FAA test questions is, draw it out on some scratch paper first, and then go to the figures book where they, give the little displays, and what you'll see right away that there can only be one display on there that matches the one that you're looking for. So looking at this example here, and first thing we want to do is rotate it to where the HSI representation is facing north. We see with our to from indication that the VOR is off to our right and that our course line is down south of us. So because the VOR is off to our right, we must be somewhere in where the green squares are, and because the course line is to our south, we must be in the upper left-hand quadrant. And there's only one airplane that's facing, we are looking for an airplane that's facing northwest in the upper left-hand quadrant, and you can see there's only one. The FAA tests, sometimes they show a couple airplanes that are up in that same quadrant. So you're looking for the one that's facing the direction that, it shows that you're flying. Looking at this one here, so here we have, we're dialed into the 090 course to the station. We're going, relative to what we have tuned in there, we're going from the station, and we have a needle deflection there. So again, if we rotate it to north, you can see that right away it shows that we, the relative to us, the VOR is off to our left. Therefore, we're on the right side of things. And the course line is to our north, which means that we're south of it. So that means that we must be southeast. Once we know that we're southeast, we're just looking for an airplane that's also facing to the southwest. And you can see letter D is the only one that that example works with. When we're talking about ILS indication, a localizer symbol, the thing to understand about the HSI is that it does not reverse sense, meaning it will always show you where you are relative to the course line, so long as you have the course needle set to the ILS, what we call a front course. Every ILS has a front course and a back course. So the front course is your left and right indications as you're approaching the runway for the instrument approach. The back course would be, as you depart, you're still going to get the same left-right indications, but on occasion, you could be flying the opposite direction on a back course, which with a VOR you actually be reverse sensing, but with an HSI you won't be. So long as this is tuned to the front course. So the front course always has the shading on the right-hand side. Back courses always have the shading on the left. Also, they usually will depict the outer and middle marker, and that would indicate that they're displaying the front course indication. So if we, again, the trick to these is to rotate the display until north is facing up, and what that's going to show you right away is that with the course needle off to your left, the only one, with the course needle off to your left, if you're going this direction, which we are, and the course needle's off to your left, then you must be to the north of the course line here. So that would be indicated by letters C as well as letter B, but not letter A, because letter A is facing the wrong direction. That one's heading east, and the other two are both heading westbound. So B and C are the ones that we're looking for there. Looking at the next indication here, we have an HSI that's tuned to the front course, and we have a right needle deflection, and we are facing the west. So we're facing west, we have a right needle deflection, so if we pretend like we're flying that direction, and we have a right needle deflection, then letter E is the only one that matches, because that's the only one that's on an actual heading of west. The other two are facing to the northwest, so they would have a indication, showing a northwest heading. So letter E is the only one that it could be in that example there. Looking at this one here, we see that we are tuned to the front course. So we have the course needle selected to the 270. We have a needle deflection that's to our right, which means that we are somewhere on the south side, and we are facing a direction of northwest, which means that we are going to be in positions D as well as F. Both of those would coincide with that indication there. All right, now this one here, a lot of times you want to be careful about going too fast through FAA test questions, because you might miss little things that can cause you to get the wrong answer. We call that the attention to detail. And so what we're looking for here is, yes, we are tuned to the front course, so that's okay, even though it shows that we're facing east. So that means that we're still going to be indicating correctly. So we're pretending that we're going that direction. We have to go to the left to get on course if we were going that direction. So that's showing that the course line is down to the south. And now even though if we're going to the east, it's still showing that the course line is off to it would show that it's off to the right. So that you can see that you're still not going to be reverse sensing. So we're just looking for the aircraft that's somewhere north of the course line and heading eastbound. So that would only be letter A is the only one that would match up with that. All right, doing some more attention to details here. The tricky part on this one is that you already have the answer. Anyway, we're set to the back course, which means that we have the HSI set incorrectly, which means that we are now reverse sensing. which means that instead of flying to the needle, we say that we are the needle. Whenever we're reverse sensing, we say that we are the needle. And we can say here that if we were heading westbound and we are the needle, then that means that we're somewhere up here. Uh, and we are facing a direction of west, so that means that it's going to be letters B and C. Whoop, wrong button, wrong button. Okay, look at these kind of questions. So here we have a localizer tuned in. Uh, we're heading westbound. We have, you know, on the VOR, whenever we're tuned to an ILS station or a localizer, what we have in the OBS doesn't really matter. We put it up there for reference, but it doesn't actually do anything. Uh, it's always going to be tuned automatically to whatever the front course is on a VOR indication. And so going on the front course, we can see that we have a left needle deflection. That means that we're somewhere to the north. Uh, and we're heading westbound, looking at the heading indicator indication. So that would mean that we were, position C there. Man, I think I got an error on that one, so we're just going to skip past that. Bing. All right. So position C on that one. Now, this one here, we got a left needle deflection, and we're heading eastbound. So that means because we're going the wrong way on the radial, that means that we are going to be reverse sensing. So uh, we are going to be the needle. So if we are the needle, that means that we have to go that way to get onto our course line if we're heading eastbound. And so that means that we must be up in position A because we're heading eastbound and we are the needle. So again, that's because we have, on a VOR, only tunes to the front course. If you're doing a back course approach or otherwise flying on the back course of the localizer, if you're flying 180 degrees off of what the inbound course is, then you are going to be reverse sensing, which means that to get on course, you're trying to bring the needle to the center. And you are the needle. That's you over there. And that's your course line. All right. Hope you had fun with all that. Now we're going to talk about holding patterns. Holding patterns are the bane of most IFR pilots' existence. We don't have to do them very often, thankfully, but we have to be ready to do them. And so we need to know, it's good to know how and why they're used and how to reference the data we need to get the job done on a holding pattern. So when we talk about holding patterns, the purpose is a method of, well, they have several purposes. One of the basic purposes is a method of delaying aircraft. For example, if you're trying to come into our airport and at a non-towered airport, they only allow one IFR operation into or out of the airport at a time. And so if somebody ahead of you had been cleared for a departure or cleared for an approach, then they cannot clear you for an approach until that person is talking to air traffic control and they know that they're out of your way. So what they might do is put you in a holding pattern to wait your turn for the approach. Uh, so that way they're going to provide separation. It could also be used to provide terrain avoidance, especially when we get in airports in mountainous areas. They may have a departure procedure that has you going to a holding pattern, staying in that holding pattern until you are able to climb up to a minimum altitude before you can go on course. And the same could be used on an arrival. You could use a holding pattern to lose altitude before continuing on course. We use them on instrument approaches, probably one of the more common ways that we use them, is what we call a method of course reversal. So that means that we use the holding pattern as a tool for getting ourselves turned around and on the final approach course for the airport. Also on an instrument approach, they are going to be used for a missed approach procedure. So if for some reason you do the approach and you're not able to land, you have to do a missed approach procedure, which is going to take you to a holding pattern. And once you're in that holding pattern, you're trying to figure out what your next steps are going to be. Are you going to do the approach again? Do you need to go to your alternate airport? Are you going to try to do an approach at another airport? But they are a part of that. It could also be used as what we call an arrival at a clearance limit. So on occasion, typically when we're given our IFR clearance, we are cleared all the way to our destination airport. But if traffic doesn't allow or some other restriction exists, you may get cleared to a fix or a point shy of getting to your airport, a VOR intersection, a GPS intersection. In either case, if you arrive at your clearance limit and you have not received your additional clearance to proceed beyond that point, then you're expected to enter into a holding pattern there and request that further clearance. It also plays a big role in lost communication procedures, which might be the reason why you didn't get that further clearance that you were planning on when you arrived at your clearance limit. In either case, we'll discuss that in detail later, but for the purposes of a holding pattern here, on the en route chart, sometimes they will depict a holding pattern on there. So you can see this little gray racetrack there is depicting the holding pattern. And so you got the little arrows there that show that it is a left-hand turn holding pattern. And so upon arrival at that fix, you would do the recommended holding entry, which in this case would be what we call a direct entry. We're going to discuss that more later. And you would just start circling in that racetrack pattern there. If there is no hold depicted at the clearance limit, then you just enter into the hold on the course or radial that you arrived on. Here's an example of using a holding pattern for terrain avoidance. So in this departure procedure, using runway 20, says you're going to do a climbing left turn and thence, meaning you're going to go follow these instructions. You're going to go direct to the ALS VORTAC, continue to climb on the ALS VORTAC holding pattern, southeast right turns on the 301 inbound radial. And then you're going to depart the VORTAC at the minimum en route altitude or minimum crossing altitude prior to getting on course. And so I drew out here is basically what that would look like. Uh, we're going to be making a climbing left turn to the Vortec. We do the entry procedure. This one's calling for a teardrop entry. We get into the holding pattern. We climb to our minimum altitude, and it says if we're going to be going southwest bound that we have to be at least 14,800 feet. So we'd have to climb in that holding pattern until we reach that altitude, and then we can get our turn on course. Hopefully you brought your oxygen with you. Here's an example of using a holding pattern as a method of course reversal. Huh. So what we want to do is relative to the direction that we are approaching the VOR, so assuming that we're coming inbound from this direction, you always want to make sure you look at the notes here. And here it says no PT, which stands for no procedure turn, is authorized for arrival on the Vortec radials 100 clockwise to 204. So that means that if you're arriving anywhere from this sector here, what you would do is proceed inbound to the Vortec, or I'm sorry, the VOR DME, and turn onto your next course line. That's what you would plan to do if you were cleared for the instrument approach. If, however, you're approaching from another direction, so we're approaching from the northeast, then we would use our parallel entry procedure to fly outbound, get established inbound, and then continue on our instrument approach. When you're using a holding pattern as a method to get established on the inbound course, you're not expected to do any actual turns in the holding pattern. That's what they refer to them as turns. If you need to do any turns in the holding pattern or any loops, maybe to lose altitude that you need or get the airplane set up or better established, you actually have to request that from air traffic control. Otherwise, if you're cleared for this instrument approach, you're expected to just go outbound, turn around, get back inbound, and then proceed inbound on the instrument approach. So again, if you need extra turns there for whatever reason, you have to request that specifically from air traffic control. When you're giving a holding clearance, it's always going to contain this information. The holding fix, so the point from which they want you to hold, is going to tell you the radial course. So radials, whenever we talk about radial, we're always talking about a from indication. If we're talking about a course, we're always talking about a to indication. A bearing would be from indication. They might mention an airway or whatever route they want you to hold on. The leg length, so the standard is to do what we call a 1 minute inbound holding pattern. However, if they give you a distance they want you to fly, then you would do that instead of doing any timing procedures. They're going to give you a direction of the turn if non-standard. So standard turns in the holding patterns are right-hand turns. So unless you're told to do left-hand turns, you would assume that you're going to do right-hand turns. And they're going to give you what we call an expect further clearance time. So they don't want you holding in perpetuity. So if you're going to be in a holding pattern for any reason, you're going to get an expect further clearance time, and that plays a role with our lost communication procedures. If we're coming up close to the expect further clearance time, we would want to ask air traffic control for either a new expect further clearance time or clearance to continue on our flight. If we found that we lost radio communications, then we would plan to leave the holding pattern as close to our expect further clearance time as possible and continue on our routing as appropriate. Again, we'll go over that, the loss communication procedures in more detail later. Some standard entry procedures. So it says you want to reduce your holding speed within 3 minutes of your estimated time of arrival at the holding fix. And they list some maximum authorized holding speeds. So if you're from the minimum height up to 6,000, the maximum speed that you could do a holding pattern is 200 knots, and then it goes to 230, and then above 14,000, you can see it's 265 knots. Now, when you're flying a, general aviation airplane that's not cruising along at more than 200 knots typically, then technically you don't have to slow down into the holding pattern. You just have to be, 3 minutes prior to the holding pattern or entering the hold, you have to be below the minimum holding speed. It is, however, recommended, if you're doing an instrument approach or you're going to end up in this holding pattern for a little while, that you should slow to maybe a low cruise speed, because generally speaking, anytime that you're holding, you're wasting fuel. So by slowing down and making sure your mixture's leaned out, you can get your fuel burned down a little bit. So also, if you're going to be doing an instrument approach, a lot of times it's best to get slowed down to your approach speed that you're going to do prior to entering into the hold. But again, so long as you're below 200 knots, there's no specific requirement that you do slow down. You're going to make all turns during the entry and while holding using a standard rate turn, which is 3 degrees per second. Not to exceed 30 degrees of bank for the faster airplanes. Typically, airplanes flying the speeds that we fly, we're usually, for a standard rate turn, somewhere between 15 and 20 degrees of bank, so it shouldn't be a big deal for us. Using entry procedures. So these are recommended entry procedures. We identify 3 of them: the parallel entry, the teardrop entry, and the direct entry. Keep in mind that these are only recommended, highly recommended, and on your flight test, I think the examiner is expecting that you're going to do these. There's a lot of FAA test questions that ask you what is the recommended holding entry procedure, but that being said, there are, and I'll go over a few here in a second, but there are some different holding techniques that I've seen other pilots do, and some of them actually work out pretty good under the right circumstance. But using the parallel entry, when we look at the holding pattern, we've got the holding fix. We've got the holding radial, and then the holding pattern. Then we're always drawing back to the holding fix and making right-hand turns. And we draw the reciprocal off of there. And then to determine, entry procedures are determined, by where you're approaching the holding pattern from. So we would draw a line 70 degrees off of here. And so this would be 110 degrees there. And we call this side of the holding pattern, this would be the fix end. Sorry. This is your outbound end. This side here is often referred to as the holding side or protected side. Protected from what? Protected from hitting that big mountain right over there. So this side here is called the non-holding side. Or the unprotected side. Uh, Now, some different rules of thumb. If you know you're approaching the fix on a 240 radial, or I'm sorry, 240 course to the station, which means that you're technically coming from this direction. Then some things that we could say about coming from this direction is that we're coming from the fix end protected side. And if you remember the letter P, whenever you're coming in from the fixed end protected side, we're generally going to be doing a parallel entry. If you're coming from the fixed end unprotected side, then boo-hoo, we're not protected, so we're going to be doing our teardrop entry. And anytime you're coming from the outbound end, most of the time, I should say, coming from the outbound end, it's almost always going to be a direct entry, which means that you're just going to turn directly into the hold. So coming from this direction, we would hit the fix and we would parallel the outbound course, which doesn't mean that you're going to be on that course line. You actually don't want to be directly on the course line, but you should just turn to parallel your outbound course. You're going to go outbound a minute, and then you're going to make a turn towards the protected side. So in this case, it's going to be a left-hand turn to set up the book calls for a 30-degree intercept angle to join the inbound course here. Uh, Based on winds in actual practice, I usually use about 45 degrees. Uh, you can see though, uh, if we were to turn and get actually on the outbound course, which some pilots do, uh, then that means that you're going to go outbound farther, which is going to take you longer to get back to the inbound course. And you're only a minute from the station, so that doesn't give you a whole lot of time to get yourself on and reestablish back to the holding fix. So that's why you do want to, just kind of parallel the outbound so you don't have as far to fly when you come back inbound. Hmm. Now, if we're coming from the teardrop side, then if we're approaching from this sector here, we're going to cross the fix and we're going to establish a 30-degree outbound heading. 30 degrees offset from the outbound radial here. So in this case, that would be turning to a heading of, if that's 180 down there, there's going to be a 150. We fly outbound for a minute, and then we're going to make a right-hand turn to come back in and join the inbound course. Once you're flying back inbound to the VOR, you want to tune in the 360 radial or course to the station so that you're not going to be reverse sensing on your way back in. And if we're coming inbound from anywhere else out here, Then we're just going to cross the holding fix and make a turn directly to the outbound course, go out a minute, and then make a right-hand turn to join right into the holding pattern. So those are your 3 entry procedures. We got the parallel, teardrop, and direct. Now what I like to do, and this might take some practice one-on-one, but in the airplane, you can draw the stuff out the way I showed you there and figure this stuff out, but the problem with that is when you're in the airplane and you get a holding instruction and you don't have a lot of time to, try to draw stuff on your knee board while you're still flying a plane in the clouds, getting close to the VOR, then it's good to have another technique for figuring out the recommended holding entry. And the holding entries are actually based upon the heading that you're flying as you approach the station. So because of that, then we can use the heading indicator to as a tool to help figure out what holding entry we want to do. And you can actually use this technique on a lot of the FAA test questions too, because they usually give you some heading indication that you can use as a reference to use this technique. But if you're going to be doing right-hand turns, then you're going to use your thumb to draw a line that's mentally draw a line or a pencil or something that's 20 degrees up from east and then 20 degrees south from west there. So you're just going to mentally draw that line and then you're going to draw a line straight up. And using this technique, whatever's in the smallest piece of the pie belongs to teardrop, whatever's over here belongs to parallel, and whatever's over here belongs to direct. And then all you have to do is know what your holding radial is. Again, the radial is the outbound course on your holding pattern. So, for example, if I was told to hold southwest on the southwest on the 210 radial, then I see that on my heading indicator I'm flying north. So I look for the 210 radial, and I see that it is down here. So that tells me right away that I'm going to be doing a direct entry, which means that once I cross the holding fix, I'm going to be making a right-hand turn directly to 210 to get into that holding pattern. If I was told to hold northwest on the 300 radial, then I just find the 300 radial. I see what piece of the pie that landed in, and it's in the parallel piece of the pie. So that tells me that I'm going to want to do a parallel entry when I approach the holding fix. So once I cross the holding fix, I'm going to be making a left-hand turn to 300, fly outbound, then another left-hand turn to come back in and get into the holding pattern. So the other thing that this does is it helps you visualize where this holding pattern is going to be relative to you and your arrival at the holding fix. One more here. We've done direct and parallel. I wonder which one we'll do now. Well, anyway, if we're told to hold northeast on the 030 radial, then we identify the 030 radial, see what piece of the pie it's in. It's in the smaller piece of the pie, so that tells us it's going to be a teardrop entry. And so to know what heading we're going to fly, you always, we want to get that 30-degree offset angle. So you just count 30 degrees towards the top of, always towards the top of the heading indicator. Count 30 degrees, and that tells you what outbound heading you want to be on. So in this case, we would just cross the holding fix and continue outbound on a 360 heading, go out for a minute, and then make a right-hand turn to come back in and join into the holding pattern there. So I know this may seem a little confusing now. It makes a lot more sense when in actual practice. And the nice thing about it is you're already going to be watching the heading indicator, so it's a great tool to have to figure this out. Other stuff that we have to do within a holding pattern, if we're just doing a standard hold, where we have to achieve a 1 minute inbound leg, then what we have to do is account for wind drift while we're in that holding pattern. So we have a little acronym that we use to help remember what those calculations need to look like. And what we would do once we enter the holding pattern, and we make our first outbound turn, when we're at the perpendicular point, and so if we're using a VOR, when that flips from a from indication back to a to indication, we would start the timer. And we time outbound for a minute, and then we make a turn inbound back to the station. And once we go, here you just want to be as consistent as possible, but once you go wings level, you want to time how long it takes to get back to the station. So in this example, let's say it only took 50 seconds to get back. Well, we want that to be a minute. And you would think that, well, I could just add 10 seconds to the other side, but unfortunately it doesn't work that way because we have to account for wind drift that happens while we're making that turn. So what we want to do is if we are over a minute, we would divide that by 2 and then subtract it from our next outbound. In this case, we're under a minute. So we multiply that by 2. So we're under by 10 seconds. We multiply that by 2, gives us 20 seconds. And we add that to our next outbound. So that means the next time that we go outbound, we want to go outbound for a minute and 20 seconds. And then we would time our next inbound leg, see what that time ended up, and any further adjustments that we would make would be relative to, the minute and 20 seconds. And you just keep adjusting until you finally figure out what outbound timing you need to achieve a 1 minute inbound leg. But that's our goal, is to achieve a 1 minute inbound leg. Other stuff that we have to account for is wind drift while we're in the holding pattern. So in this example here, we have wind blowing, directly off our wing. And so what that's going to cause then is our holding pattern, as we enter the hold here, we're going to get blown away from the hold. And if we turn directly to our outbound leg of 238, that wind is going to continue to blow us off course, and that turn inbound is going to be much smaller. And so you can see that we're not going to be on our inbound course. So what we'd have to do is, as we're making this turn inbound, we're watching the VOR indicator, and if that needle is still pegged over to in this case, the left side there, we would stop our turn early, leave in about a 30-degree intercept angle, continue to find our inbound, and get on our inbound course. And now, sometimes this requires a little bit of witchcraft getting going here, but the book says that if we can identify what our wind correction angle is going inbound, so let's say that we're trying to we had to maintain a 5-degree wind correction angle inbound, then what we would do is triple that correction outbound. So we would want to next time we went outbound, we'd want to roll out of the turn. Well, we go uh, 15 degrees past 238 to find a heading that hopefully will get us to where we roll right out onto that inbound holding course. Uh, knowing where the winds aloft are while you're flying is extremely useful because I talk about, sometimes if the winds are really strong, you could get blown so far off course. If you just parallel your outbound course, you can get blown so far off course that even with a 30 or 45 degree intercept angle, you never make it back to the holding radial before you've already crossed the station. I've even had it happen where we end up, never even getting back to the course, and we're already seeing the needle flip from a to indication to a from indication, which means that you're past that perpendicular point. So if you know the winds are going to be blowing from a particular direction, and this comes with a little bit of experience too, but uh, it's good to hedge your bets a little bit and kind of pick a heading uh, that you think is going to get the job done, and then you can use that as your initial reference for making any further corrections down the road. I'm going to be sending this uh, PowerPoint to the folks in the instrument class there, and what I want you to do is use these flashcards to kind of go through and practice determining what the correct holding entry would be based on the information that we have. So on these cards here, we get a instruction, and we have a heading indicator showing us what our heading is as we approach the station. So again, there's two techniques to do this. One is to draw it out. The other way is to use the heading indicator itself to figure out your holding entry. I'll uh, I'll go through. I'm not going to go through all of these because I have quite a few here to give you plenty of practice. But I'll go through a few of these here with you to show you the different techniques that you can use. It's good to be comfortable with both techniques. One that might help you out while you're taking the test better, one that will help you out in the airplane better. It's always good to have a couple ways of doing things. So looking at this one here, if we look at the holding instruction, we're told to hold south of the VOR on the 220 radial. So what we'd want to do is draw that out. So we draw our VOR and we draw the 220 radial. Now when they tell you southwest or whatever it is, that's just a general direction that you can expect the holding pattern to be in. What you're actually holding on and what you're referencing is whatever they give you right there. Things you want to be careful about is, when you receive the holding instruction, that what they say here in your head agrees with what you see here. Make sure those two things agree with each other. So for example, if they told you to hold northeast on the 220 radial, then I'd want to get back with air traffic control and get that instruction clarified, because the two don't coincide with each other. So it's possible that you misheard the instruction, or I've also seen and heard the controller give an improper instruction. And unfortunately, that actually happened to one of my students on their check ride. Anyway, hold southwest of the VOR on the 220 radial. So we draw out our 220. Again, that's the radial that we're holding on. We want to draw our hold heading back towards the VOR and a right-hand pattern because it didn't say left-hand turn, so we assume right-hand turns. We draw our line here, and then we can label that stuff. So if that's 220 down here, that's going to be 040 up there. That's going to be 70 degrees there, so that's going to be a 330 there. That's going to be 150 down there. And then we just look and see what heading we're flying. So here it shows us flying a 280 heading. And so we just draw our little airplane out there heading 280 degrees towards the station. And we can see that the piece of the pie that we're coming from, if we're going in at 280 degrees, is going to be in the parallel entry side. So we're coming from the fixed end, protected side, so that's going to be a parallel entry. Using our heading indicator technique, we don't have to draw any of that stuff out. All we have to do is identify the 220 radial. We draw our up 20 and down 20 here with our line straight up. That's going to be our teardrop, parallel, and direct. So we see that the 220 lands in the parallel entry spot there. So both of them were telling us to do a parallel entry. And that is correct. And so on the picture that I show here, that when I made these years ago, made sense in my head. But anyway, that's what the holding pattern is going to look like relative to north. The dot here represents the direction that you're flying to the station. So it's just kind of showing that you're coming in at the holding pattern from that direction. And so you're coming from this side, so that's going to be a parallel entry side. Try to figure these out with me as we go through them here. We'll go through a few. So on this one here, we are told to hold northwest of the VOR on the 330 radial. So if we're going to draw it out, we draw our VOR, we draw 330. We come back to the VOR, draw a right hand racetrack pattern. We draw our 70 degree line here. And we can draw a reciprocal out there. So that's 330, so that's 150. That's going to be minus 70 degrees, so that's going to be 80. That's going to be the reciprocal over here, so that's going to be plus 2 minus 2. That's going to be 260. And we see that we're currently inbound on a heading of 220 degrees. So that means that we are approaching the VOR from somewhere up here, which looks like we're going to want to do a direct entry. So we would cross the VOR, go outbound, and turn right into the holding pattern there. Using the heading indicator technique, we're told to hold on the 330 radial. We see that that's down there. Draw our little up 20, down 20. We can see it's in the biggest piece of the pie, so that's a direct entry. Done. And that's what it looks like relative to north there. All right. Okay. I think, let's see what we got here. So here we're going to hold south-southwest of the VOR on the 190 radial. So again, we draw that out. We got 190. We draw it back to the hold here, draw our right-hand racetrack pattern. It's good to draw that reciprocal line out there. And then we're going to draw a line roughly 70 degrees off of there, and then we just want to label everything so we don't screw it up here. So we got 190, That's going to be 010. That's going to be 120. And that's going to be 300. And here we're approaching on a heading of 150. So that's 120, that's 190. So that means that we're kind of approaching, there's 150 somewhere over here. So we're kind of coming at it like that. So we're coming from the fixed end, unprotected side. So that's going to be a teardrop entry looking there. If we look over here, we hold south-southwest on the 190 radial. We just identify the 190 there. Again, we got our up 20, down 20, and our line straight up. It's on the smaller piece of the pie, so that's a teardrop entry. Do one more here in this style, and I'll look for a different style or a different type here. So here we're told to hold west-northwest of the VOR on the 285 radial. So we draw our VOR, draw our 285, come back to the VOR, draw our right-hand racetrack pattern, draw our reciprocal out there, 70 degrees here through 110. Label everything. So that's going to be the 105 over here. Minus 70 is going to be the 35 up here. And that's going to be plus 2, minus 2. So that's going to be the 215 down there. We see that we're approaching the VOR on a 060 heading. So that's 35 and that's 105. So 60 is going to be somewhere over here. And that's the direction we're flying. So we're actually coming in at the VOR from over here. So that looks like it's coming from the direct entry side. So I would guess it'd be a direct entry there. We can look here for 285. See that it falls in the biggest piece of the pie. And so we know that that's a direct entry. Hopefully you can see I'm trying to sell that heading indicator technique as the fastest option. Now, sometimes you gotta be careful because they could be some tricky ones. Let's see what we got here. There we go. Okay, so things to watch out for. If you get one that has left-hand turns, then you can still use the same techniques. It's just everything gets reversed. You got to do the mirror image of it. So here we're told to hold east of the VOR on the 090 radial left-hand turns. So if we draw that out, we're going to draw our VOR. We're holding east on the 090 radial. We're going to draw back to the VOR. This time we're going to draw our racetrack to the left. Left-hand turns. We're going to come up here, draw our reciprocal, and then we got 70 degrees there, 110 over there. Label everything. So we got 090. We got 270. So we got 340 up here and 160, or I'm sorry, Yeah, 160 down here. We're approaching the station on a heading of 060, which puts us, there's 90, so 60 somewhere over here, and that's the direction that we're approaching the fix at. So we're coming from, this would be your teardrop, the smaller piece of the pie, then we got our parallel coming from the protected side on the fix end, and then we got the direct entry. So coming from that direction, it's going to be a parallel entry. Using the holding pattern technique, we just identify the holding radial, and all we got to do is just reverse our lines. Instead of drawing up 20, down 20 on the right side, oops, sorry. We're going to draw up 20, down 20 on the left side, and then straight up. So now this smallest piece of pie becomes our teardrop. That's going to be our parallel, and that's going to be direct over there. So that radial leans in the parallel side, so we're going to plan to do a parallel entry, which means that as we cross the fix, we're going to turn outbound to 090, fly out for a minute, make in this case, a right-hand turn to come back and join the holding pattern, and then start doing our left-hand turn holding pattern there. And there you go. I give plenty of these to practice on, and I'll be sending that to you within the next day or so, and I highly recommend that you become very familiar with picking a holding pattern entry. A holding pattern is going to be a part of your flight test. Oftentimes you get a holding instruction with not much time to react, and so the better you are at picking that holding pattern, the more confident you're going to feel about getting into that holding pattern. And yeah, drawing the flight path out on the heading indicator, that works good too. Bring yourself a little dry erase marker. And talking about drawing the flight path there. So this would be your flight path approaching the VOR there, coming from the bottom. But take a few minutes if you guys have any questions. Otherwise, that's all the material I'm going to go over tonight. But just if you got any questions, go ahead and pop them up there now, and we'll see what we got going on. With the streaming, there's about a 6-second lag. That's the lowest I was able to get it, but still gives you, I think, pretty good quality on the other side. Thank you, Kevin. Good to hear from you there. Hope things are going well out in Buffalo area for you. Leslie, thanks for joining in. Yeah, exactly. Gotta love those moving maps. A lot of times with the holding patterns, if you're looking at a holding chart, uh, it is easier to visualize or on a moving map, because then you can just kind of go through those little questions. Am I coming from the fixed end or the outbound end? And if I'm, a lot of times you can figure it out without doing any math. Aloha to you too, Dan. Uh, the less you have to do math in the air, the better off you're going to be. And knowing that you're coming inbound from to the holding pattern from the fixed end protected side, it's going to be a parallel entry. Uh, let's see. Well, when you're actually doing, once you're in the holding pattern, just to answer Dave's question here, uh, once you're, again, there's different techniques that you can do here. Uh, if you're asked to get into this holding pattern and you're arriving somewhere over here, which is going to call for a teardrop entry, uh, I know a lot of people, and the way I was trained is once we cross the fix and we're doing our entry, we tune to the directly to the inbound course line that we're going to be holding on. So if I was told to hold on the 360 or the 180 radial, I would tune the thing here to 360 on my OBS for reference. However, I find sometimes it helps during the holding entry so you can see where you are relative to the radial that you're going to be getting on, is that after you cross the fix, you can tune to the outbound. So you tune, in this case, to the 180 while you're doing while you are outbound. That way you'll be able to see where you are relative to the radial. But once you make your turn back inbound, you do want to make sure that you tune in the inbound course line. As far as the teardrop heading, to figure out what heading you want to do, uh, to figure out what heading you want to do. So if I was told to hold on the 090 radial, that's over, well, no, that's not a good example for what we're asking, sorry. Let's say I was told to hold on the 160 radial. So that's over here, and that's going to call for a teardrop entry. And so to know my outbound heading, I'm looking at the 160 and I want to count 30 degrees towards the top of my heading indicator to figure out what my outbound heading is going to be. So it's going to be 10, 20, 30. So after I cross the fix, I'm going to turn to a heading of 130 to get into that hold. If you were doing a left-hand turn holding pattern, so for example, let's say that you were told to hold on the 130 radial left-hand turns. So 130 is over here. And if you're doing left-hand turns, up 20, down 20, and then up, that's going to call for a teardrop entry. And so you would count 30 degrees towards the top of the heading indicator. So 10, 20, 30, and I would go outbound on the 160 radial. Uh, hopefully that one of those answers your question there, David. But if nobody has anything else, I'm going to go ahead and sign off for the evening. Everybody stay safe, stay healthy, and don't breathe too heavily, I guess. Don't touch stuff. All right. Have a good night, guys.